Hello everyone, so before we start our lesson on 5.5 apply remainder and factor theorems, I want to review long division just a little bit. I know it's going to seem weird, but we will actually completely use what you did like in, I don't know, 4th grade or something. So the first thing that we do when we do this is we look to see how many times 13 will go into 27. 2 times, so then we get 26, and then we subtract, and we get a 1, and then we bring down the 4. 13 goes into 14 one whole time. 1 times 13 gives me 13. Then I subtract, because this was a positive 13, so now it's minus 13. And I get a 1. And then I bring down the 5 again here. 13 goes into 15 one whole time. And then I get 13 again. I'm going to subtract, which means this was a positive 13. Now it's minus 13. And then I get 2. Old school would have been remainder 2 or R2 like we used to do, and then we learned how to do fractions, so then we would write this as 2 over 13. The remainder goes on top of the number we were dividing into. So now what I'm going to do, because this will prepare us for the notes, or what I want us to do is to write down and review what we just did. So the first thing we did was we saw how many times 13 went into 27. Obviously the name of that is division. I know it's going to seem like I'm being condescending, but really, everything you did in elementary school, if there was like, ooh, I really don't remember that, it's going to mess us up when we get to this polynomial long division. Setting you up for success. The next thing we did, after we divided and got this 2, we multiplied 13 by 2 and got 26. So my next step is going to be multiply. And then, after we multiplied and got this 26, we had a positive 26, but we subtracted, which means we change signs. And then fourthly, we had this 26, we subtracted and we got a 1, and then we brought down. So next we bring down. And then if we need to, we could repeat if necessary. If you want to, you can put if necessary in there. I won't, because I'm running out of space right there. So thinking about those steps, you will absolutely positively need to memorize those. Okay, if at any time during this lesson you need to pause, please do. If you need to rewind, please do. That's the joy of having it flipped. And then today you're going to work on your 5.5 homework assignment, and then after that you will hopefully complete it in groups if you need to, or work with a friend if you have to, and then you won't have homework over the break. So let's try to get to this. So long division, if you remember, whatever I'm dividing by is going to go on the outside of this still, so I'm going to write that as x minus 5, and then I don't remember what this is called, division house I suppose, 3x squared minus 11x minus 26. So going back to your steps, the first thing that we did was to divide. So when we divide for polynomials, you don't have to divide this whole thing into this whole thing. It's just not easy for us to wrap our minds around. So instead, we're going to look at the first terms. Actually, if you'd like to, you can go back up here and give yourself a note and put first terms, because that might help us out just a little bit. So what are my first terms? Well, my first term here is 3x squared, and my first term for here is x. So when I divide those two terms, I'm going to get, well, 1 goes into 3 times, and then when I'm dividing and they have the same base, I'm going to subtract the exponents. So x to the first power, but really we don't really write that, so it's just going to be 3x. What do I do with that 3x? Well, it's an x term, so I'm going to put it right above this x term. My next step was to, after I divide, multiply. So multiplying 3x, distributing of course, times x is 3x squared. 3x times negative 5 is negative 15x. Next on your list of steps is to subtract. So when we subtract, basically we're going to change signs, but the only thing here is you have to remember to change both signs, or every sign that's over here. You can't just do one without the other. Hashtag, you'll get it wrong. Hashtag every time. So then you're going to subtract this, nothing happens, so these kind of cancel out, which is great because that's what you need it to do. Then you have negative 11x plus 15x, and that gives me 4x. After we subtracted, our next step was to bring down, so minus 26. Then you start over again. So the first step that we did before was to divide. And again, I'm looking at the first terms here. So I'm going to divide 4x by x. Now these x's cancel out, and all I have left is 4. So I'm going to write, it's a positive 4, so I'm going to make it plus 4 there. Next step, multiply. So 4 times x, 4x. If this number doesn't match when you multiply, you did something wrong. 4 times negative 5 is negative 20. And then we're going to subtract. So 4x minus 4x is nothing. Negative 26 plus 20 is negative 6. Now we have our remainder. So think back to what we did in the warm-up, or just look up about 3 inches. And we will put this as minus, because it's negative, 6 over x minus 5. Minus 5. And that's my final answer. I know you want a box, but a box is not easy to do on this little screen, so accept it. It's just fine. Okay, number 2, same thing that you just did. I want you to look at it though and think back to what we did when we did synthetic division, and see if you can predict what I'm going to do here in just a moment. I don't have a problem with this. X squared minus 3x minus 2, and this will still be the same. This is 4x to the 4th. Remember when we were doing synthetic division or synthetic substitution, we had to put 0 placeholders because this does not go 4, 3, 2, 1. It skips some terms. It skips x cubed and x squared. So I'm going to write that as plus 0 x cubed because there aren't any of them, but I need them to have 0 placeholders, and plus 0 x squared. This 5x falls right back in line, so I'm going to write that, and then minus 4. Alright, then you go through your steps once you have this set up. At this point, if you feel pretty confident and you feel like, okay, that's cool, I get it, I'm going to try it on my own, there's a lovely pause button that I would love for you to press if that is you and you are about that life. If not, and you want to just kick it with me a little bit longer, let's go ahead and divide first. So first terms again, we have 4x to the 4th divided by x squared. 1 goes into 4 times. X squared goes into x to the 4th. Well, you subtract the exponents and you get x squared. This 4x squared is going to go right above the x squared terms. If you didn't have that 0 placeholder, you'd be like, where do I put it? No, you don't have to. 4x squared. So the next thing that we did was to multiply. So 4x, and then now if you're like, okay, yeah, I see you now, you can go ahead and pause at any point if you feel like you can. I'd be very, very proud if you did. 4x squared times x squared is 4x to the 4th. 4x squared times negative 3x is negative 12x cubed. And this should be flowing pretty well. Like the next one should obviously be x cubed because we put those 0 placeholders in there to make sure that everything was okay. 4x squared times negative 2, negative 8x squared. I've just multiplied, so that means my next step is going to be to subtract. And when I subtract, I'm going to change all of the signs. So this is nothing, and this is 12x cubed. 0 plus 8 is positive 8x squared. And then I'm going to bring down my plus 5x. Then we're going to do what we did last time, and now we're going to repeat, which means we're going to divide now. So 12x cubed divided by x squared is 12. Subtract the exponents, x. So plus 12x. And then you're going to multiply, which means you're going to distribute everything everywhere. And what I'm going to do is let you do this like solo on your own without me. I know, traumatic. But I'm going to pause my writing, and I want you to really legit pause if you haven't really done so already, and then make sure that you match what I'm going to have. All right, so how'd you do? Did you get a little bit afraid when you got that 44 and then you multiplied and you got some crazy big numbers? I did. I double checked my work like 3 times, but I think we got it. So press pause, check your work with my work before moving on to the next section. Yeah, those numbers really just are that big, but I think you did okay. I hope you did okay. Onward, synthetic division. So now I'm going to show you the part of this that you're going to actually love to do because it's a million times easier. Why don't we show you this first? Because then you would never do long division because you would just resist it all the way. So synthetic division, if I tell you in directions that you have to use long division, you really do legit have to do it. I'm saying that because I do know that you're going to like this more. The only thing that we have to think about for this problem is this x minus 2 when we divide. You know when we're doing long division how we have to change signs? Well, now you only need to do it once. And so this now becomes a positive 2 for synthetic division. This changes all the signs at once so you don't have to do it step by step. So this is for negative 13 and negative 13. Remember for synthetic division, the first thing we do is bring down. Sounds familiar? 2 times 4 is 8. Now we'll subtract or add actually by combining like terms and get negative 5. 2 times negative 10. 2 times negative 5 is negative 10. And something is correct. And so then when I combine these terms, I get negative 23. So here's the thing. I'm going to write this instead of going from left to right, from right to left, because this, what we had before, is now going to be my remainder. So it's going to be negative, and it's going to be 23 over what we were dividing by, x minus 2. Now, if you look back up on your papers, other way, it should go remainder, then a constant, then your x term, then your x squared, and if there was one, there'd be an x cubed, so on and so on. So that means the next thing I should have is my constant. So this is going to be negative 5. And then before the constant is your x term. So for x. Should go in order. So constant, remainder, and then just keep building up from there. And that would be your final answer. Kind of a lot faster, I know, but it is what it is. I do want you to know both methods. So if you're looking at this next problem, the first thing you're going to do, change sign. So now instead of this being plus 5, negative 5. I'm going to set you up and then let you check your work with my work. Coefficients here are 1, 4. There's no x squared term here, so put a 0 there. And then 16, and then negative 35. Do this now, and then press pause for now. I'll rejoin you in a moment, and then you can check your work with my work, including writing it in the correct form. Okay, so this is me here, and this is what I got. And remember, this is my remainder, so that's going to be the part that's over the fraction. After that, you just go from the constant, x, x squared, x cubed, because this is actually like a 1 if there was an exponent, and this is like having x to the 0 power. However, no one writes those because it's just not a good look in terms of notation. It goes back to you saying, oh, I'm 15 times 1, or 16 times 1, or I'm 15 to the first power, or to the 0 power. No one does that, so don't. Okay, the next part that we're going to go over here, and I hope you like that as well, is the factor theorem. And that says that a polynomial f of x has a factor x minus k if and only if f of k is a 0. Now here's what that means in regular people's terms. This is saying, if remember when you had to solve by factoring, we would break that down into like let's just show you, x plus 2 times x minus 3 equals 0. You would set each of these equal to 0. You'd find that x was equal to negative 2 and x was equal to 3. That's great. But what we're doing now with this k is saying that if I were to plug this back in here, I would get a 0. Because negative 2 plus 2 is 0. And 0 times this number would still give me 0. They're saying that these factors translate into zeros. So when you have given a factor, you're going to translate that as in k, f of k equals 0. I know, that sounds weird. Don't worry. I'll clean it up on the next video because I'm running out of time now. So basically, though, all you're going to have to do is change the sign here. So I'm going to have you do that.